Good evening, ladies and gentlemen. Welcome to the Environment Society News Flash. Today we're going to be talking about systems thinking and how the agriculture model, industrial model, plays into the systems thinking. So I'm your host, Amanda Saunders.
And I'm your other host, Lauren Ripley. And we have a beautiful live audience with us today. We have Drew McConnell, and we also have Morgan Kennedy behind the camera. Thanks for the studio audience.
So, systems analysis approach, a discipline for seeing the whole. It is a framework for seeing interrelated relationships rather than things, for seeing patterns of change rather than snapshots. System, interacting, interrelated, interdependent elements forming a complex whole. Systems thinking asks questions like, what are the underlying relationships? What are the connections that create the problems that we're experiencing? And what are the drivers?
So first we're going to talk about climate change and the underlying relationships of climate change. So first we have too high concentrations of greenhouse gases in the atmosphere lead to an enhanced greenhouse effect. That means that there's too many greenhouse gases in the atmosphere, which leads to excess solar energy being pushed back to Earth instead of it being released to space. This leads to increased surface temperature, and it also leads to global warming. That finally results in climate change.
So what are the drivers of climate change? It's a complex system. So we have economic systems. A driver is a structural root cause of a phenomenon that they are beyond the realm of individual decision making. So economic systems that are driving climate change are the materials economy, growth domestic product. The political systems is capital logic, and cultural systems are the consumerist logics.
So first we're going to look at level 1 thinking, which is the top of the iceberg, something that we can see. So this thinking is reacting to observable events or problems, using band-aid fixes to stop the problem. And it also asks what's happening or what has happened.
So systems thinking level 2, just right here on the iceberg. Seeing connections between problems and observing patterns, fixing problem by disrupting the pattern, and it asks questions like, has this happened before? Is this similar to other problems? What are the, oh wait, is that the right one? Okay, sorry, my bad.
So systems thinking level 3 is down here. It's a little lower on the iceberg, but not as deep as level 4, which we'll get to in a moment. So what are the social systems that promote the pattern? It's fixing problems by making other changes within the institution that promote the pattern. And it asks what forces or structures are behind the problem, what forces or structures are driving the issue.
So systems thinking level 4 is the bottom of the iceberg. What are the dominant beliefs that are held? What are the values and ideas that people hold pertaining to the problem? Structures are shaped by society's values. Fixing the problem by changing people's beliefs and ideas. Why are the structures organized the way they are? What beliefs about the world are the structures built on?
So now we're going to get into the module 4, which we are going to be talking about, which is industrial agriculture. So what is modern industrial agriculture? The modern farming technique that endorses maximizing production while limiting the costs. This means industries have invested in cheap labor, usually involving mechanics, which involves the use of chemical fertilizers to speed up growth of agriculture. To limit costs, agribusinesses also employ the use of monocrops, which is the farming of one type of crop year after year on the same land. We're going to be talking about that more in depth later with the systems thinking.
So industrial agriculture and the underlying relationships of climate change. This is how agriculture relates and causes climate change. Too high concentrations of greenhouse gases in the environment leads to an enhanced greenhouse effect, increases surface temperature on the Earth, results in global warming, thus causing global climate change.
So what are the drivers of industrial agriculture? Just like climate change, we have some of the same institutions that are driving agriculture. So first is economic systems in the materials economy. Mechanization is driving industrial agriculture as well. Political systems, like capitalistic logic, international trade and policy support, and cultural systems, overconsumption, increased population and supply and demand. These are all connected together.
So features that are indicative of industrial agriculture are monocrops. Well, the first one is monocrop. A monocrop is a crop which does not change year to year and remains on the same land. For example, if a farmer is growing a monocrop of corn, the farmer will grow corn year after year on the same grounds. This leads to biodiversity loss as well as a change in land systems and fertility. The technology, this increases the use of fossil fuels, which affects climate change by adding greenhouse gases to the environment. Technology is used to harvest as well as upkeep agricultural crops and land. It allows the farmers to limit the cost of labor. Chemical fertilizers. Chemical fertilizers include fixed nitrogen as well as phosphorus, which is used as nutrients for the plant to grow, as well as to refertilize the soil that the crops is grown in. These chemicals run off farm into the topsoil, into water systems, which leads to the ocean. This causes ocean acidification as well as pH imbalances, and a lack of oxygen in freshwater systems, and this can lead to the aquatic dead zones.
So when we look at systems thinking, we first looked at planetary boundaries. So what are the planetary boundaries that industrial agriculture affects? It affects biogeochemical flows, biosphere integrity, land systems change, and climate change, and we're going to be looking at those now.
Industrial agriculture and land systems change. Am I on this?
No. Biogeochemical.
Oh, sorry. Industrial agriculture and biochemical flows. Chemical fertilizers are products synthetically created or mined for the purpose of adding nutrients to plants that need to grow in the soil. As a result of monocropping and lack of rotation in plant species, the soil lacks the nutrients needed for productive growth. As a result, chemical fertilizers are used to provide phosphorus and nitrogen to the plant. Because agriculture takes over wetlands, when rainfall increases, the crops flood and phosphorus and nitrogen are carried into the water systems. These water systems eventually lead to the ocean. This leads to the dead zones that we were talking earlier. Due to oxygen depletion in the water, as well as microorganism depletion due to the chemicals emitted into the water, this is shown in Canada in Lake Winnipeg and Lake Erie. These lakes have experienced out-of-control algae blooms, which is a consequence of phosphorus leaking into the environment. The pre-industrial level of nitrogen and phosphorus was 0. Currently, the level of nitrogen being emitted is 150 teragrams a year, and phosphorus is 22 teragrams a year.
So industrial agriculture and biosphere integrity. So what is biosphere integrity? Biosphere integrity relates to the scale and impact of the human relationship on ecosystems. The two main categories are biodiversity and functional diversity. Biodiversity is the variety of species on life on Earth, and functional diversity is the range of things that organisms do in communities and ecosystems. Industrial agriculture brings about change in biodiversity by introducing monocrops. Monocrops erase any diversity as a single product is grown year after year in the same dirt. This leaves no room for weeds or varying plants to grow and also destroys animal habitats. Another change is in the soil fertility, as growing the same crop year after year depletes the soil of nutrients, meaning nitrogen fixation is required. Because of the monocrops, they take away anything that's in the dirt except the plants, so no decomposing plants, animal material, or manure is used.
Industrial agriculture and land systems change. Land is converted to human use all over the planet. Forests, grasslands, wetlands, and other vegetation types have primarily been converted to agricultural land. Because capital logic involves high production, lots of land is being formulated into agricultural landscapes. This is because with more land, more crops can be yielded, leading to higher production rate. Changes in land systems lead to habitat loss. And habitat loss leads to species extinction and biodiversity loss in the environment. These ecosystems that naturally consist of a diverse variety of species of plants, animals, and microorganisms that symbiotically work together to stabilize the climate are being depleted by huge amounts. With massive amounts of land being used for the industrial agriculture all across the world, the systems left over are overwhelmed and then changing the climate.
So industrial agriculture and climate change. The production of fertilizers includes the emission of greenhouse gases into the environment. 1 ton of nitrogen fertilizer requires the use of 873 cubic meters of natural gas. The use of industrial equipment to harvest the crops also releases fossil fuel emissions into the atmosphere.
So industrial agriculture and systems thinking level 1. Food waste. 1/3 of the food that is produced becomes waste. A family will typically throw out a week's worth of groceries a month. Processing plants throw away 20% of food waste. Supermarkets throw out 10% of the food waste, and consumers contribute 47% of food waste. Consumers contribute to the most to the food waste at 47%. There is an excessive amount of food produced.
So industrial agriculture and systems thinking level 2. So this is seeing connections between problems and recognizing them. So first, as we mentioned earlier, phosphorus is flowing downstream from crops' topsoil runoff. This has happened in Lake Winnipeg. Because the farms have invaded the wetlands in Winnipeg, when heavy rainfall occurs, topsoil runs downstream into Lake Winnipeg. It's filled with pesticides, which includes phosphorus. And what happens is Lake Winnipeg begins eutrophication and becomes a dead zone. This results in vast algae blooms. So we've also seen this with Lake Erie in the 1960s. It was said that Lake Erie was dead. This was also a consequence of phosphorus being leaked into the waters. It was phosphates in detergents that were used in the sewage treatment plants. And because of this, the government banned the use of phosphates in the treatment plants. And Lake Erie was restored to its original state.
So what is the pattern? The phosphorus and nitrogen that run in and cause the eutrophication, increasing the growth of algae, means that eventually the fish will die. They're no longer able to breathe.
So, industrial agriculture and systems thinking level 3. So for this one we decided to talk about palm oil. So what is conflict palm oil? It's palm oil that is produced under conditions associated with the destruction of rainforests, expansion on carbon-rich peatlands, and/or human rights violations, including failure to recognize the customary land rights of forest-dependent communities, and the use of forced child labor and other labor as well. So what systems are driving this conflict palm oil? The materials economy is driving the conflict palm oil because it's found in more than 40% of household products. Most companies that use palm oil are purchasing conflict palm oil, which is responsible for mass deforestation of the rainforest and the extinction of the orangutan, as well as, like I said earlier, countless human rights violations. But most of the large companies do not have deforestation policies in effect, nor do they purchase sustainable palm oil.
So industrial agriculture systems thinking, level 4 of the iceberg, which is what is the dominant held beliefs. Food is a fundamental human necessity. We need to eat to live. However, we think that it is necessary to use massive industrial systems to be able to feed everybody, and we are convinced that we need to consume more than we actually need. And this is how we justify such a system.
So in conclusion, industrial agriculture is one of the main drivers of climate change. It affects every single planetary boundary, however we only looked at, I think, 5. Humans produce and consume way more food than is necessary, and we need to eat to live, not live to eat.